Welcome back. Now we'll look at paper 41 from May-June 2024. And well, I mean, as we see here, right, this is a 2 hour 30 minutes paper. Hopefully I can keep this to 1 hour 30 minutes. However, I would recommend watching the video at double speed, or at least 1.5 speed perhaps. Right, then it says you'll need the candidate source files. So these, I mean, if you just go on like any past paper website, you can find these, right? They'll be the text files. Also this evidence doc, and if I just show you this one, I mean, hopefully people are familiar with this already, but I know some people, they're completely confused, like they've never seen any of these files before. So I mean, well here then, this is where we just copy and paste our code, and also some of them it's going to have, for example here, right, copy and paste a screenshot. This is just our answer document. Right, then it says, well, we can use a high-level programming language, either Java, Python, or Visual Basic. Now, what I'm going to do, I'm actually going to use Java, but I mean, I'm going to try to keep the video quite language independent. And what I'm actually going to have is on the side of the screen, I'll also have the code for Python and Visual Basic. So no matter what language you're using, okay, you should be able to find these videos useful. But yeah, I mean, I think for introduction that should be enough, and well, let's just sort of jump into it. Right, it says open the evidence document, evidence doc. Again, you should have downloaded that from the past paper website. Now, of course, in the real exam, I mean, this should already be open right on your computer. I suppose for your teacher or the exam invigilator, they should have downloaded that for you. Got everything set up. Right, it says, well, make sure your name, sentence number, candidate number, appear on every page, right? Because I think this one you just have to put in the header of the document. Right, then it says, save the evidence document. Again, well, this is the file name, right, followed by your sentence number, candidate number. They give you an example. Right, then it says a class declaration can be used to declare a record. If the programming language used does not support arrays, then a list can be used instead. So I guess, this is saying for Python, right, because Python technically doesn't have fixed size arrays. Right, it says one source file is used to answer question 2, right, the file is trees.txt, so again, you can download this from the past paper websites. Right, anyway, number 1, because that's all just intro. Right, a program needs to take integer numbers as input, sort the numbers, and then search for a specific number. The integer numbers will be stored in the global 1D array data stored, with space for up to 20 integers. Right, the global variable number item stores the quantity of items in the array, that the array contains, and we want to write the program code to declare data stored and number items. Okay, so hang on. Right, so then it says, well, save your program as question 1, right, J24. Right, copy and paste the program code into part A in the evidence document. Now, I mean, I think really we can probably save this as anything, because honestly, like, the only thing they're going to mark is actually the evidence document. I guess, well, maybe let's just copy this and we'll just, create a file with this name. Right, so I'm just going to use IntelliJ here, and let's just go new Java class. Right, let's just save that, or create that. Then, I mean, well, IntelliJ is quite nice because, for example, rather than having to type like public static void main, and let me just minimize that. If we just type main, well, then it's just going to automatically create that for us. Right, then it says what it wants a global variable. So I think the first one was going to be an integer array, and what was that? I think data stored. I think that's what they called it. Let me just check. Data stored and number items. Right, so let's go data stored, and we'll just go new int array, and let's make that size 20. Okay, storing 20 integers. Right, then let's also go, this will be number items, so I guess, so I mean, here we don't have to initialize it with anything, so I think here, I mean, hang on, right, we could just initialize that with 0, just as a default value. Now, I mean, this is kind of okay, but like, if we do actually try to use this, let's see what, see here it's not even going to suggest it. The reason it suggests it is, the reason it doesn't suggest it is because we see here, main is going to be a static method, and then, this number items we haven't declared as being static. So for example, like if I just try, number items, right, 1, 2, 3, right now if we just hover over this, saying non-static field number items cannot be referenced from a static context. So basically that's saying, this main procedure, right, is static, because we define that keyword here. Then what we want to do, if we just go make number item static, again, that's just going to make this static. And again, let's just do that here then for data stored. And yeah, let me just delete that. Alright, so for question 1, I mean, this is all we have to do, and then of course we just take this, and then we would just go ahead and, yeah, in this one here, and then of course we would just paste that in here. Now, I mean, okay, yeah, that does work. Now, I mean, probably one thing actually, you might not want to paste it, you know, with this actual formatting. I mean, I think it's okay if you do, but yeah, although actually no, I think that they do say it should just be black and white. So what you'd probably want to do, maybe just, yeah, so you probably want to go, keep text only, just so it, you know, copies and pastes in black and white like that. Alright, and then yeah, if we go to the next one, so the procedure initialize prompts the user to input the quantity of numbers the user would like to enter. It will read the input and validates it's between 1 and 20 inclusive. Right, prompts the user to input each number and stores the each number in data stored. Okay, so right, we just want to write this initialize then. So to create this initialize procedure, well, let's go public static. Right now it's going to be void because it's a procedure, there's no return type. Right, then if we just go initialize, and I think, yeah, this takes no parameters. So to get user input, well, we're going to go scanner, and I mean, we can call it SC, right, or we can just use scanner as they recommend. Right, then let's go new scanner. That's going to take system in as parameter. And then I think what I'm going to use, I'm probably going to use a preconditional loop. So I'll ask them to enter the input, or yeah, I'll ask them to enter, I guess the number of items. And then what if it's, let's say, yeah, if it's less than 1, right, or greater than 20, right, then we're going to ask again. So let's go S out, and I mean, yeah, so this is if you're using Java, and if you're using IntelliJ in particular. Of course, you can just type S out, right, then press enter, and then, yeah, that's going to do the whole system out print line. So, yeah, let's say maybe enter, like, amount of numbers. Yeah, I think that should be okay. Or, yeah, maybe amount of numbers to enter. Right, then what we want to do, so we want to go number items, and we're just going to go scanner, and that's going to be next int. So whatever, I guess, well, whatever integer they type in, yeah, this scanner.nextInt, that's just going to, you know, sort of extract the integer, right, from the input. Right then, well, yeah, so of course, I mean, well, yeah, I guess it could be valid the first time, but obviously if it's not valid, well, here is the validation. So, right, let's go number items is less than 1, right, or number items, and, well, let's say more than 20, right, greater than 20. Here, let's go S out. Yeah, well, alright then, well, what I'm going to do, I'm just going to copy this. Right, let's say, yeah, or I don't know, maybe let's say error. Should be, yeah, let's say what should be between 1 and 20. Let's say try again. Yeah, and then I think that should be okay. Alright, and then there was actually a part 2 to this, where so prompts the user to input each number and stores each number in data stored. So, I mean, here we actually don't need any validation. Yeah, so for this, I mean, we can just have a simple for loop. So, okay, yeah, right, let's go for, let's go maybe in x, or yeah, in n, right, doesn't really matter. Right, I'm going to go 0, and let's go what n is less than, and that's going to be number items. Right, then if we just go, yeah, I guess what n++, and right here, then I'm just going to paste it again, so we can say, you know, like enter number 1, enter number 2. Right, so let's go get enter number. And then obviously, well, here, I mean, technically this starts at 0, but I mean, let's kind of output in a more human, like, friendly form. So I'm just going to get n+1, right, just so it says, yeah, enter number 1, right, rather than enter number 0. And then, yeah, I'm just going to have the colon, right, just to, yeah, to sort of, you know, tell them they need to input. Right, then here, then, this is going to be, what is it, data stored. And, yeah, that's then going to be the index n. Alright, so I think that should be okay, and then if we just call this, so let's go initialize, and what I'm going to do, I'm just going to do an s out, and then if we just go, yeah, okay, so we go data stored. Now, I mean, it should give us an error, and it's going to say, well, if we just output this, right, technically it's going to output the memory address, so yeah, that's why we can wrap it with this, well, arrays.toString expression. So yeah, this will just output it as a string, basically. And then I think, I mean, if we run this, so yeah, let's wait for that to compile. Right, let's see the number of numbers. Let's go like -5. Yeah, error should be. Alright, so let's try 0 again. Yeah, that should also be an error. Let's try 21. Alright, that's an error. And let's just try 3, right? Something small. Right, let's try maybe 7. Let's go 3. And let's say 4. And yeah, okay, right, this seems to work. Now, of course, here we do have this array of 20. But I think it's fine because, well, for example, if we need to, I don't know, maybe we need to find the total or something like that. Well, then, we can just loop up until this number of items. Because, yeah, this number of items is kind of like the end pointer, effectively. I mean, alternatively, you can actually modify the size of this array. So, yeah, okay, let's go right after we've actually validated the number of items. You could go data stored. And then, yeah, can we just assign this to be a new int? I'm not sure if it's going to let us reassign it like this. Yeah, okay. So if we do this, well, let's just try run this again. Right, so let's try 3, I don't know, let's try 4, 5, and 6. And then, yeah, we see in this case, right, now we just reassigned the array, or to be a new integer array, right, just with 3 elements. And again, of course, you just want to copy and paste that code right into part B. So yeah, just copy and paste the whole initialize procedure. Right, then the main program stores 0 in number items, calls initialize, and then outputs the contents of data stored. Okay, write program code for the main program. I mean, alright, so well, technically we've actually sort of done this already. But I think rather than actually just using this arrays to string, I mean, well, let's actually just use a loop to do it. And I mean, we could use, okay, hang on. Okay, so yeah, let's say we could use a regular, for loop like this, right? Just using the start and index, what the condition while true, right? While we're looping, then of course while the step or the sort of increment decrement amount. But if we have an array and we just want to, simply output things, well, then we could also just use a, well, let's say enhanced for loop. So yeah, right, that's going to be enhanced like that. I mean, that's what it's called. So with an enhanced for loop, well, first we say the data type, so that's going to be an int, because well, each of these items in the data stored as an integer. Right, I mean, let's just call this n. So yeah, this can be anything, right? It's just a sort of local variable or a temporary variable. Right, then we have colon, and then we say the, I mean, let's say the sort of array or the the object, because I mean this could also be like an array list or a hash map, could be other things as well. So yeah, let's say like the object that we're kind of looping through, or iterating through. So in this case, that's going to be data stored. And then here's, I mean, well, what this is going to do is it's just going to loop through each item in data stored. It's going to call that n, and yeah, here then we can just output n like this. And yeah, this should also work. Now, equivalently, we could also do, let's get what 4, I mean, let's call it something different this time, where x is 0. So again, we go where x is less than the number items. Right, then we just get x plus plus, and then this time this is going to be data stored. And then it's just data stored x. So I mean, if we look, I mean these two for loops are going to be identical. Now, of course, I mean this one has the advantage of being shorter, right, just more concise. I mean this one has an advantage that, well, sometimes we actually do need the index. Because I don't know, like maybe we need to do some processing, based on a specific index, or maybe we want to output the index number, something like that. I mean, if we don't need the index, right, then of course we can just use this. And to be honest, even if we did want the index here, like we could just go index 0, and then of course we just go index plus plus, and so of course, well, this would still give us access to the index in this case. But anyway, I'm just going to delete all of that, and I'm probably just going to use this enhanced for loop, right, just since it's shorter. And again, I mean, I think, I suppose like maybe we can test this, although, I mean, so how many items is that, right? 7. Alright, so maybe let me just paste those there. And I mean, well, just check it's working. Right, so here it's going to be 7 numbers. Right, then we want 30. Right, then 5. Right, 3, 9, 4, 1, and 2. And then if we look at this, hang on. Okay, so well, now you can see then we've got this, and I mean, wait, why is output 30? Okay, all right. So yeah, 30 was number one. All right, that's correct. And yeah, 7 was the size. And then of course, well, this we would just want to take a screenshot of the outputs, and then yeah, paste the screenshot again into the evidence document. Okay, then it says the procedure bubble sort uses a bubble sort to sort data and data stored into ascending numerical order. Right, write program code for bubble sort. Okay, so yeah, let me just minimize that. Right, and then, I mean, like, honestly, I mean, here, of course, we can do it anywhere, but I'm probably just going to do it below this initialize. So again, right, public static, right, this is going to be a procedure, so let's make it void. And then, yeah, let's go bubble sort. And I think it said it doesn't need any parameters. Yeah, I mean, since we're just using the global array. Let's just have a super quick recap then of how to actually do bubble sort and the two optimizations. So if we've got an array, I don't know, maybe 2, 4, let's say 7, all right, 5, and 1. Now, if we think on the first pass, well, of course we do what, 2 and 4. Well, I mean, 2 is smaller, therefore we don't swap them. Right, 4 and 7 again. Right, that's the correct order. Don't swap them. Right, 7 and 5. Well, they will get swapped. So yeah, let me just write 5 there. Of course, right, this one's going to become 7. Then again, well, 7 and 1. All right, also they're the wrong order. So yeah, they're going to get swapped. Because of course, well, we're just checking, is 2 bigger than 4? All right, no. So yeah, don't swap them. So if we notice that, well, on the first pass, we see that the biggest element has now become in the sort of rightmost position. Like then if we just do the same thing the second pass, well, again, right, 2 and 4, they're going to stay in the same order. Right, 5 and 1, they're then going to get swapped. And then, yeah, we see here we're now 5 and 7, okay, they're in the correct order. I mean, likewise, the next time we're going to get the 4 here. I guess, yeah, we're going to have the 2 and 1 like this, right, then the 5 and the 7. So, I mean, as you can see, well, each time, one more element is getting sorted, which, well, I mean, what that means then is, well, let's say, after the first pass, right, we then don't have to check this rightmost element because we know that's already sorted. After the next pass, well, we then don't have to check the 2 rightmost elements because, again, they're sorted. Of course, yeah, the next pass, right, the 3 of them. Right, so that's going to be the first optimization. Right, the other optimization is, well, if it's already sorted, of course, then we just swap. Then we just stop, right, not swap. And of course, well, the way we check, if it's already sorted is if we just check, well, have we had to do any swaps or not? And if we've not had to do any swaps, well, then we know it's sorted. Yeah, so I think really that's everything. And, one thing people do get, well, sometimes maybe people get confused about is they think, well, here we've got 5 elements, right? Therefore, we need to loop, 5 times. But actually, we only need to loop up until this sort of, let's say, 4th element. Or well, if we're starting in, sort of index 0, right, that's going to be, well, the 3rd element. But basically, we start by looping to the size of the array minus 1. And the reason for that is because, well, of course, we can compare element 4 with 5. But if we loop up to here, this, well, 5th element, or again, right, index 4 in a 0-based array. But yeah, if we loop up to this end element, well, like, we can't then do this element, right, compared with, sort of n plus 1, because, of course, well, there is no element here. Yeah, that's why we only go up to the second to last element on the first time. So let's just see if we can code this then. Right, I think if we just create the boolean and let's just say maybe is sorted. Now, I mean, by default, well, let's go false, right, because we want to assume it's not sorted. Right, then let's also go int, and this can be the end index. Yeah, okay. Right, so as we said, well, the end index, well, this will be the number of items, right, so the size of the array, and then just minus 1. Yeah, and then, I mean, that should be all we need. So let's just go here then. Well, we're going to have the... Yeah, okay, right, well, let's just go while. So we're going to say, right, well, while is sorted equals false. And then, yeah, here it's going to give me an optimization. It's going to say, well, we can simplify this, right, just to, well, not sorted. Yeah, of course, right, that's equivalent. Right, then inside here, we then just want to have a for loop, just looping through, each element by element. So let's go int. I mean, well, this will be the current index. I mean, let's just call it index. Right, this will start at 0 because, well, obviously 0-based arrays. Right, then we want to loop, and this will be what while index is less than the end index. So just, yeah, looping through all the elements. Right, then if we just go by index plus plus, right, so just increment the index. Then what we want to do, we want to check, well, okay, hang on, probably one thing. yeah, I should have probably put this is sorted and just assign that true. Because what we're going to assume is, well, we're going to assume it's sorted, and then if we have to swap them, right, then we just set is sorted to false. So right here then, well, we just check if they're out of order, and of course the way they're out of order is if the current element is less than the next element. So right, that's going to be data stored, this will be index, and yeah, if this is less than, alright, okay, right, no, okay, there we go. Right, so yeah, data stored and then what, index plus 1. Okay, and hang, right, yeah, sorry, that should be greater than, not less than. Right, then in order to swap them, well, let's just make a temporary variable. Yeah, well, that's going to be an integer. And right here then, I mean, let's just assign this. I suppose, right, if we assign this the current element, so let's go, right, data stored and index. Right, then what I'm going to do, I'm going to move the next element into this current element. So if we go data stored index, and that's going to equal, right, so we're going to assign it. Right, data stored and then index plus 1. Right, then we just want to move the temp into the, well, you know, data stored index plus 1. So yeah, into the next element. And again, I mean, hopefully people are familiar with that, but just to recap, of course, what we're doing is, well, I mean, let's just call it n here. Then we've got to say n plus 1. Right, then we've got the temp. Now, let's say, I don't know, maybe we have 2 in this n. Right, maybe n plus 1 has the value 3. Yeah, or I suppose, hang on, well, yeah, I guess that's not, I mean, that's not the best example because, of course, that's sorted already. I mean, let's just swap them, right? So let's say it's 3 and 2. Right, so what we're doing then is, well, first we're going to move this 3 into the temp. So yeah, this becomes 3. Right, then I think we move what, the n plus 1 into n. So we're going to move this here. So effectively what, this 3 now becomes 2. Right, then the final thing was we moved what, temp into this n plus 1. So yeah, this 2 now becomes 3. And of course you can see, you know, just with this extra temporary variable, right, now we've actually managed to successfully swap them. But yeah, I mean, I think hopefully most people should remember that. Alright, and then I think just one more thing we need to do, so we just want to go what, end index minus minus, just to decrement that. And yeah, let's also go actually inside this if, of course, what we want to set is sorted to false. Alright, and then I think, yeah, that should work. So is it saying we probably have to call it? Okay, no, so we just want to write program code for bubble sort. Yeah, alright, however, what I'm going to do, well, because if we look, hang on. Right, it does say, well, the next one, yeah, we want to call bubble sort and then output the contents of data stored. So I'm just kind of going to do both of these. And to be honest, of course, what it would be good to actually test it, you know, don't just write bubble sort, you know, just copy and paste the code and yeah, sort of like assume it's working. Yeah, first make sure to actually test it. Right, and yeah, then of course when you've tested it, right, when you've confirmed it works, well, then copy the code into the answer document. So yeah, I mean, let's just see if this works then. Right, let's say enter, I don't know, let's go 4 numbers and we'll try 9, let's try 4, right, 3 and 2. And then we get, yeah, 2, 3, 4, 9. Okay, so yeah, this seems to be working. And of course, I mean, here, well, yeah, you would obviously want to input this, but right, I'm not going to do it just to keep the video a bit shorter. And then, of course, yeah, take a screenshot of the output, yeah, just showing that's working. Right, then the function binary search takes the integer parameter data to find, right, to search for in the array, performs an iterative binary search on the array data stored. Right, it's going to return the index where data to find is found in data stored, and if data to find is not found, then returns -1. Okay, so yeah, just write program code for the iterative function binary search. Right, so again, let's just minimize this. And right, since this is a function, well, again, we're going to go public static, but this time, rather than void, okay, we're going to return an int. And yeah, this is going to be binary search. Right, this takes an integer parameter, what I think they said, data to find. Yeah, was that what they called it? Yeah, okay. Right, so binary search, I mean, what, again, let's just recap how this works. So, alright, yeah, there we go. Alright, yeah, just choosing the pen. So of course, well, I mean, first it has to be sorted, right, hence why we need the bubble sort. Now let's imagine we just got an array like well, just 1, 2, 3, 4, 5. What we're going to do then, we're going to have a start pointer, which is going to point to the first element in the array. The end pointer is going to point to the end element in the array. Right, then we're going to get the middle position. So if we think, well, here then the the start pointer is actually 0, okay, because of course, well, again, array start is 0. Right, in this case, what the end pointer is going to be 4. So what we're going to do then, well, then we're going to generate the middle index, right? The index of the middle position. So the way we do that is going to be what the start pointer plus the end pointer, right? Then just divided by 2. And note, this is going to be integer division, right? Like obviously we wouldn't want, for example, 2.5. Yeah, we need to make sure to round that down. So in this case, well, this is just going to return 2. And then what we do, well, okay, so let's say we're trying to find the element 4. Well, then what we're going to check is, well, is the current element sort of bigger than the element we're trying to find? And then, well, we see in this case, right, since the element we're trying to find is bigger, well, therefore we know that the element we're trying to find, well, either it's going to be in this second half of the array, right, or it just doesn't exist. So what we can do, well, we can remove this start pointer, and then, yeah, we can just set the start pointer to be the mid plus 1. Right, then, of course, we can do the same where we just think, right, so this is going to be index 3. Right, so well, 3 plus 4 is 7. Right, 7, yeah, integer division 2. Right, that's going to return 3. So, of course, well, that's going to compare it with this one. Of course, in this case, we found it. Now, let's imagine if we're instead trying to search 5. Well, again, we're going to have the same problem, right? Obviously, well, yeah, 5 is bigger than 4. Therefore, what's going to happen then is, well, the start pointer is then going to go to 5 as well. So in this case, we see the start pointer and end pointer are equal. And of course, yeah, finally, we found it. So let's say you're trying to find element 6. Well, now what's going to happen then, again, the start pointer is going to plus 1. So we say, well, the start pointer is here, you know, the end pointer is here. And what we can say, well, this will be our end condition. So of course, well, if the start pointer is bigger than the end pointer, right, of course, well, then we can stop. Yeah, so I think basically we just want to loop while let's say the start pointer is less than or equal to the end pointer. Yeah, that can be when we're looping. Okay, so yeah, let's just try and code this then. So if we think about the variables we need, well, one is just going to be the start pointer, and right, I mean that's just going to start at 0. Right, I mean I'm just going to declare them all on one line here. Right, then if we just get end pointer, so the end pointer we said that's the number of items, right? But then remember just minus 1, because well again of course the array starts at index 0. Right, and then I suppose mid. Yeah, okay. So I think actually mid I'm probably not going to assign anything at the moment. Yeah, just leave that empty. Right, and then what we can do, well, let's say while, so this would be while start pointer is less than or equal to the end pointer. Right, first what we want to do, we want to calculate the mid. So the mid we said, well, that's the start pointer plus the end pointer. Right, and then divided by 2, and let's put that in brackets, right, just to make sure. Yeah, just to make sure it does the addition first, right, then divides the whole thing by 2. Now, if you are in Python, I mean, you will actually have to use, I think, is it going to be the floor function? Yeah, of course, I mean, I'll have the correct code in the side. But with Java, we don't have to do that because, well, if we have, let's say an integer divided by an integer, like, for example, let's just say this, right, like 5 divided by 2. Well, 5 divided by 2, right, because 5 is an integer, 2 is an integer, then in Java, I mean, that's just going to equal 2. Of course, in Java, if we want to get actual decimals, well, then we need to declare it as a float or a double. But yeah, I mean, integer division is, well, the default, right, if they're integers. Okay, so, right, then we can just check. So we want to check if the current element is correct. Okay, so in order to do that, well, let's go, right, yeah, data stored, and this will be mid, right, this is the index we calculated. Right, if this is equal to the data to find, well, then we just want to return the index. Okay, so the index is just mid. Right, then, well, let's have an else if, and we can say, well, if the, let's say if the current item, so that's data stored mid, right, if this is greater than the data to find. So, right, if we just go back to the diagram again, so let's say here then, Again, or I think I'm actually just going to invert that logic. So yeah, I think maybe it's easier to do that. Right, if we go data to find, right then if we go data stored, and that's going to be mid. So let's say if we're trying to find 6, but you know the current element is like 3, well then we think it's going to have to be in the right half of the array. So what we want to do then, we want to change the start pointer, and the start pointer of this is going to be what, mid plus 1. Right, then we can just have an else, because, well, I mean, either it's equal, right, or, you know, the data to find is bigger, rather than the else, well, this must mean the data to find is smaller. So right, if the data to find is smaller, well, then we just want to set the end pointer, and that's going to be what, the mid, and then minus 1. Yeah, I think that should be okay, right, then if we just go, what, return minus 1, yeah, I mean, just don't forget that. Although, I mean, this is, say, one advantage of, let's say, Java, right, it's, you know, especially using IntelliJ. Like if we don't have that, well, that'll give us an error, and when we try to compile this, it's going to say, well, missing return statement. Now, yeah, like I don't know, like maybe PyCharm might be able to do this. Although, yeah, I think actually, well, PyCharm wouldn't be able to do this because, you know, in Python you just say def, right? I mean, you don't actually specify if it's a functional procedure. So yeah, I mean, PyCharm wouldn't know like if you're, you know, sort of supposed to return something or if you don't have to. So yeah, let's go return minus 1 like that, and then, I mean, I think here, let's just, again, I mean, let's just test it, right, see if it works. And obviously, I mean, this will be a little bit slow if we actually call this each time. So what I'm going to do, I'm just going to comment those out, and let's just manually assign this. So let's just go number items, let's just say 5, and right, let's go data stored, and then yeah, here I'm just going to go, what, 1, 2, 3, 4, 5. Yeah, okay, I mean that's a bit annoying because it wants us. Right, hang on, right, let's go. Yeah, okay, alright, so I think the reason it's not letting us do that is of course because we said 20. Right, I'm just going to say 5. Okay, no, it's not going to let us do that. Right, I mean if we just copy it up here, I mean then it will let us do it. Yeah, if I make sure to have the correct commas. I mean, so I'd say, yeah, this is something that is, you know, quite useful in the exam. Like, if you just want to give it the test data, right, then of course you can test it quickly. Yeah, then, I mean, well, the thing is, if you do this, right, make sure to actually reset this back. Right, so then we just want to go, yeah, binary search. And, right, since this is a function, well, I mean, let's just say we're trying to find 1. Right, then, yeah, I'm just going to copy this a few times. And I think I'm just going to try and find all of them. And let's also try and find maybe 6, and then, for example, yeah, right, let's go 6, and then let's also go 0. Yeah, I mean, I think this should work. Yeah, so, I mean, well, obviously, yeah, this was just printing out that. I mean, we could comment that out. Yeah, all right, hang on, well, let's just comment that out just so we can see, right, only our binary search. Yeah, so saying, right, 1 is in index 0, okay, yeah, which is correct. Obviously, yeah, 2, 3, 4, and then, yeah, minus 1. Okay, so, right, this seems to be working, and now what I'm going to do, I'm just going to undo all of this. Yeah, just so we can go back to the sort of correct code, right, without this test stuff. Okay, right, then what did it want us to do? Like, probably just call that. Right, so take a number as input from the user. Right, call binary search with the number input. Right, output the value returned from the function call as its parameter. Okay, right, so I mean here then, since there's the main program, of course, well, this is not inside one of the functions or procedures. So what I'm going to do, I'm just going to copy the scanner. Right, and then, yeah, maybe let's just sort of copy this as well, actually. And then here, I mean, well, let's say, like, enter number to find. And right, let's go int, I guess, well, let's say, like, to find. And then we just want to go, what, s out, and that's going to be, right, binary search, and then, yeah, just to find like this. Okay, yeah, so let's just run this, and I think that should work. Right, let's say 3, let's say we want to have, I don't know, 7, like 4, and let's try 8. And right, let's try 7. And yeah, saying 7 is in index 1, because if we see, well, 4 is index 0, right, 7 is 1, 8 is 2. So yeah, I think that's fine. And then again, it's just saying test your program. And of course, yeah, just take screenshots, right, make sure to add those. And this one's a bit confusing, but I think they're saying, well, 5, this is the number of elements. And then of course, yeah, these like 1, 6, 2, 8. Well, so yeah, these are going to be these are going to be the 5 elements, right? And then of course 2, well, 2 is going to be the element we're trying to find. And I guess, well, in this case it should say 1, because, well, that's going to be the second element, right? So index 1. Then yeah, 7 is going to return -1. Question 2 says a computer program will store data about trees. The user can enter their requirements for a tree and a suitable tree will be selected. The program is written using object-oriented programming, and the class tree stores data about the trees. Right, so we've got the tree name string stores the name of the tree. Right, the height growth integer stores the number of centimeters the tree will grow each year. Right, max height and max width, both integers. Right, well, stores the maximum height and width that the tree will grow. And evergreen stores whether the tree keeps its leaves as yes or loses its leaves as no. Right, then the method, so there's a constructor which will initialize, I guess, all of the variables, right, all of the attributes to its parameter values. Right, then you just got getters for each of those. And if we look, I mean, the getters, there's actually no sort of validation, right? It's just a simple getter, just, directly returning the attribute. Right, it says write program code to declare the class tree and its constructor. Do not declare the other methods. Right, use the appropriate constructor for your programming language, and all attributes must be private. And well, yeah, if you're writing in Python, then include attributes declarations using comments. So just saying the data type, for example. Right, then it's saying, yeah, we should save our program as this. So right, I'm just going to copy this, and then let's go here. Then we'll go new class, and yeah, let's just create this, and then right, I'm actually just going to create a new file. Yeah, although, yeah, okay, I mean, right, I think I'm just gonna, I'm just gonna create a new file, right, just for the tree class as well. And yeah, let's just zoom in. Alright, and yeah, just minimize that. Right, so, right, well, okay, we just want to create the constructor. And if we see here, well, the constructor wants all of these as parameters. So yeah, I'm also just going to copy this just so I can see it. Now, of course, I mean, in the exam it's going to be a bit easier because, well, you're going to have, on paper. So, well, of course, you can be typing on the computer as you're looking at the paper. Yeah, you won't have to keep like flicking backwards and forwards to the PDF. Right, anyway then, so what we want to do, well, constructor, let's go public, right, that's going to be tree. And to be honest, actually there is a kind of simple way of doing this. So let's say in IntelliJ, and I guess, yeah, PyCharm will also support this as well. Right, well, we can just go tree name, so let's just define all of the attributes. Right, then we want, right, well, let's go, wait, yeah, what is that? Right, let's go, yeah, height growth. Right, then let's go, well, max height. And I suppose, I mean, if we want, of course, yeah, we can just do all of these here. Right, max width. And well, let's go another string, and we'll just go evergreen. Now, of course, I mean, well, this string we could also declare up here as well, but I'm just going to do it like this just to keep it in the correct order. And yeah, let's also remember just to make these private as well. Right, and I mean, well, the reason I kept them in the correct order is because, well, let's say in IntelliJ, right, we can then just go generate, and if we go generate constructor, right, then if we just select, well, we want all of these attributes, and then you see here, well, that's going to automatically generate this constructor for us. And of course, yeah, since we've got it in the correct order, right, it's going to generate in the correct order. Or well, it's going to generate, the parameters, right, in the correct order. But what I mean, like, rather than doing that, of course, I'm going to show you how to do it. So to create a constructor, well, let's go public, right? Then we say the class name. Of course, again, I mean, in Python, right? In fact, yeah, let me just minimize that. Yeah, obviously, while like Python, Visual Basic is going to be slightly different. And again, well, that's why hopefully I'm going to have the code here just on the right. Okay, so right then we just want to say the parameters. So the first one is going to be, well, let's go tree name. Right then again, well, let's go int, right, that's height growth. Right, we want another int, that's going to be, what, max height. Yeah, then, well, max width. And then, right, let's have a string, and that's going to be evergreen. Right, then what we're doing is, well, basically we want to assign these parameter values to the actual, well, let's say class attribute. Yeah, this private variable. Then what I'm going to do, I'm just going to use the this keyword. So here we can go, well, this dot tree name. And I mean, the reason we say this is because, well, we're saying, basically we're referring to this instance of the class, right? So basically that means, yeah, we're referring to, you know, these class attributes, right? Like rather than this parameter. So if we go, well, this dot tree name equals tree name, and in this case, well, the tree name is, you know, this parameter, right? Yeah, obviously this dot tree name, well, this is the class attribute. And I mean, well, yeah, basically let's just do that for the others. Now, technically, we wouldn't have to do this. Like, let's say, for example, if we had height growth with a small h, like, then since they got different names, we could then just go height growth equals height growth. And yeah, this is also going to work because, well, here it's going to know the only thing, you know, with height growth with a big h is, of course, just going to be this class attribute. And then, yeah, height growth with a small h, of course, that's going to be the parameter. But, like, to be honest, I think yeah, okay, well, let's just do it manually, I guess. Right, I'm just going to keep them big H like this. And yeah, let's make sure just to have the this. Right, and then let's go, what, this dot max height, that's going to be, yeah, max height. Right, then go this, yeah, max width. And we're obviously going to assign that the max width. And then finally, well, this dot evergreen. And yeah, that's going to be evergreen. And again, of course, like, well, that's how you do it manually, right? If you just want to do it, yeah, if you want to do it automatically, well, then you just right click, go to generate, constructor, yeah, select all of these. And then if we see here, well, the way they do it again is just using the, you know, sort of small letter trick. You know, of course, you also call this, like, you know, height growth param or something. Yeah, with a big H. And then, of course, yeah, just use this one. But right, well, what I'm going to do, I'm just going to delete all of this and then, well, just use the one that I've made. Okay, so I think, yeah, okay, so for part A, that should be fine. Right, then the methods, well, the getters, yeah, each return the relevant attribute. I write program code for the get methods. So again, I mean, as you can probably imagine, you know, IntelliJ can just do this quickly, right, same PyCharm. And I assume if you're using, say, Visual Studio for VB, then that should also be able to do this. So let's go, well, I mean, here then it has to be public, because obviously, well, I mean, a getter has to be public, right, just so we can access it from outside the class. And we want to say, well, what's it going to return? Now, the first one, well, tree name, okay, that's going to return a string. So, right, let's go string, and, yeah, do they use, okay, right, so here they use big letters. Right, so let's go, yeah, get tree name, and then, right, then here we just go, well, return. And, you know, right here, well, we could go, yeah, this dot tree name. However, in this case, right, we actually don't need to use this. We can just use tree name, because, again, I mean, it's not ambiguous which one we're referring to. Right, so, I mean, of course, you can do that for the others, you know, public int, right, get height growth. But I'm actually just going to use the generate here. And yeah, so I think here we just only want the getters. I mean, well, tree name we've done already, so let's just do the next four. And I mean, that's basically okay, but I'm just going to change this to be a big letter. Yeah, and I mean, like, everything looks fine, right? Public int. Yeah, okay, that should be okay. Right then, the text file trees.txt stores data about 9 trees. The data in the file is stored in the format, right, tree name, height growth each year, maximum height, maximum width, and evergreen. Right, so yeah, for example, and I guess what, just separated by commas. Right, well, the first tree is beech, right, it can grow, yeah, 30 centimeters each year, right, etc. Right, and it's not evergreen, so that means it does lose its leaves. Okay, the function readData creates an array of type tree. It then reads the data from the file, and it will raise an exception if the file is not found, creates a new object of, right, type tree for each tree in the file, and appends each object to the array, right, then it returns the array. Okay, so yeah, I'm just going to copy all this because there's quite a lot we need to do. And then I think this one, I mean, rather than doing it in this tree, because, well, this is just the class, right, I'm just going to go back to this kind of main one. So here then, let's go main, and yeah, this is where, well, yeah, of course, well, this is where we can actually, call our main program. Right, and probably it's going to say, I mean, does it want us to actually call this read data? Like, probably that's going to be the next part. Yeah, right, so I think, well, first then let's just actually create this function read data. So if it's a function, well, public, and then we want to think, well, of course, yeah, public static. But in this case, it's going to return an array of trees. So let's go tree, right, and then, well, this is going to be an array. Right, then the name, so, well, that's going to be read data. Right, and then yeah, here it takes no parameters, so if we just go like this, okay, then what we want to do, so creates an array of type tree. It's going to read the data from the file. See, now the problem with this is, well, we don't actually know how many items are in the file. And yeah, they don't actually tell us. I mean, okay, alright, so yeah, they do tell us, right, there's 9 trees. Otherwise, well, we could use an array list if we want, say, like a variable sized array, but I mean, that's actually not required for A level. So for A level, they should always tell you the size of the array. Yeah, just so you know, obviously, how big to make the array. So, I mean, well, I guess let's call this tree. Well, yeah, maybe let's call it trees. Right, so that's going to be, what, a new tree array, and then, well, of size 9. Right, and then I'm just going to show you, so I've actually loaded this trees.txt. Again, of course, you find this on the past paper websites. Yeah, just this sample data. Right, so in order to read a file, now to read a file in Java, well, let's go buffered reader. I mean, I'm just going to call that BR. Right, then we go new buffered reader, and yeah, this one's a bit complex. Right, then we go new file reader. And then inside here, well, then we just have the file name. So the file name, well, just trees.txt. And notice it will actually tell us, well, we need to surround this with a exception. So, like, I'm not going to do this add exception to method signature. I'm going to go more actions, and I'm going to go surround with try catch. Now, of course, I mean, you could write this yourself, but I mean, it's probably easier just to let IntelliJ do it. Right, then it's going to have a file not found exception. And yes, I mean, here that's this one, right, raises an exception if the file is not found. So I think that's fine. Okay, then to read the data from the file, well, then we just want to, loop through, right, while it's not empty. So let's go string, right, this would be line. And yeah, I guess we can just sort of, not assign that anything at the moment. Right, then what we want to do, so this is similar to pseudocode, like while not end of file. So make sure to have the brackets, we're going to go while line, and this is going to be, right, br.readLine, right, so the buffered reader read line. Right, and we say, well, while that is not equal to null. Right, then we're going to read it, and here it's also going to say we need to catch a different type of exception. So let's go. Yeah, I mean, maybe just add catch clauses. That would be the best one. So if there's a file not found exception, of course it's going to throw this exception. Yeah, if there's an IO exception, so I guess that's if it can't do this read line, right? Then it's obviously going to throw this IO exception. Right. So then what we want to think, well, since they're separated by commas. Right, I mean, the easiest way is just to use split, and again, Python, VB, right, they all have a split function. And then we've got to think, well, obviously we have to convert these to integers as well. So right, I'm just going to go, well, string array, and let's call it split. I think that should be fine. Right, then if we go line.split, and here then we're going to split on a comma. Right, then. Yeah, I mean, probably we can just create variables for these. So let's go string, right, this will be the name, or I guess the type. Yeah, I guess tree name, tree type. Right, and then that's going to be, well, split and then index 0, because, well, this is the first element. Right, then we want to go, so in fact, no, it's not string, right, it's an integer. And then I think, the next one. Okay, right, so the next one is the height growth each year. So let's say, like, on a yearly growth. Then what we want to do, well, we want to go integer pass int. So this will take a string, convert it to an integer. And then this is going to be split index 1. And then, right, I'm just going to copy this. And then the next one, I guess what, like max height. And then I think the next one's going to be max width. And let's also make sure that this should be split 2, this should be split 3. And then I'm just going to copy this final one. And then, well, I guess this should just be evergreen. And yeah, that can then just be split 4. Right, then what we want to do, well, we just want to add this. Yeah, of course, well, we want to add it to this trees array. So I suppose here we will also need an index, just to, you know, store what kind of, well, yeah, what tree we're on. Right, so that's going to start at 0, and then let's say, well, I mean, once we've read it, then let's go index, right, index plus, right, just so we don't forget that. And then here's where we can actually create a new instance of each tree. So, right, let's go trees, this will be the index, and then we're just going to assign this, right, that's going to be new tree. Right, then we go, right, name, yeah, yearly growth, right, the max height, max width, and evergreen. Yeah, just making sure we've got all of those parameters. Right, so let's see, well, we've created an array of type tree, yeah, reads the data from the file, okay, yes, raise an exception if the file is not found, yeah. Right, creates a new object of type tree, yeah, so create a new instance of each class, right, appends, yeah, then just returns. Right, so I think that's everything if we just return that at the end. Again, you know, this is quite nice where IntelliJ is going to say, right, missing return statement. And I mean, if we just go, yeah, okay, and then I mean, here it can even work out that, well, of course, it's going to be this trees. So I think that should be okay. Now, again, I'm just going to test it just to see if it's working. Now, yeah, okay, right, so well, if we just go read data, and in fact, like, I'm probably thinking the next question they probably ask us to do this. Yeah, okay, all right, so the next question they ask us to, well, make this print trees, so I guess we can just do it here, right, just to, yeah, test it's actually working. Right, so the procedure print trees takes a tree object as a parameter and outputs the trees, well, name, height, right, I mean, basically everything. Right, the output message depends on whether it's evergreen. Right, so if it's evergreen, it's in this format, if it's not evergreen, it's in this format, so yeah, let's just copy those. Right, then we want to write program code for print trees. Okay, so yeah, let's just delete all of this. And then, right, since this is a procedure, well, let's go, right, yeah, public static void. Right, then print trees is the name. Okay, and then, well, here it's going to take a tree parameters. Let's go tree, and, well, let's just call that lowercase tree. Okay, so what we want to think then, well, we just want to use these guesses. And we can just check, so let's go, what, if tree, and then this should, yeah, okay, let's go get evergreen. Right, so, I mean, I guess in, you know, Python or something, we can just use, yeah, like equals equals. In Java, when comparing strings, well, we should use the dot equals method. And, right, let's say, what, if it is equal to yes, so, what, if it is evergreen. Right, then, okay, so, right, so first we want the tree name, so let's go s out. Right, that's going to be tree, yeah, get name, or get tree name. Right, and let's see what has a maximum height. Right, then we just want to go, what, plus tree dot, yeah, max height, or what, get max height. Now, I mean, in Java, we actually don't need to convert the types when, you know, when concatenating them like this. However, in Python, you will actually need to use, well, I guess the string. Well, so yeah, just like int, str, right, just to, you know, convert between strings and integers. So I suppose, yeah, you'd have to use what int around this just to, okay, sorry, no, you'd have to use str, right, to convert this integer into a string. Yeah, I mean, this thing's pretty long, right, a maximum width. And this is going to be what, yeah, tree dot, right, get max width. And let's go, what, and grows. Right, so this is height growth cm a year. Okay, yeah, this one. And I think, I mean, here they wanted a space, like, yeah, I don't know, maybe we want a space between the centimeters. Right, let's say a year. Alright, and then we can just say, yeah, it does not lose its leaves. Right, so here we don't need any variable. Okay, so I think that should be fine, and then I'm just going to copy that because, well, probably it's mostly the same. So it says, right, tree name has a maximum height, yeah, maximum width, and grows. Okay, so I mean, actually, well, all of this is the same, right? The only thing that's different is, well, yeah, either you say, right, it loses its leaves, right, or it does not lose its leaves. So I mean, like, you could just have two if statements like this, with the same data. Like, I think what I'm going to do, I'm just going to have something, let's call it maybe base message. And right, the base message is going to be, I mean, basically this whole thing except for the last sentence. So what, just the first sentence, basically. Right, okay, and then what we can do is, well, here then we just want to output the base message and then plus, right, that it does not lose its leaves. Yeah, so I think, I mean, hopefully this makes sense what I'm doing here, just to avoid duplication. And the reason for that is, of course, well, if we want to change this message format, well, then we only have to change it in this one place. We wouldn't have to change it in, multiple places here. Alright, so then we say, right, it loses its leaves each year. Yeah, okay, so I think that should be okay. And then what I'm going to do, again, well, let's just try and output all of them. So, right, I mean, again, like, you could just make a normal for loop. I'm just going to use an enhanced for loop. So let's go tree, right, let's call it T. And I suppose, well, here we can just go read data like that. Of course, you could also assign this to another array. Right, then we just want to go, print trees and print, well, this T. And, I mean, yeah, hopefully that should work. Yeah, okay, so, right, this one says it loses its leaves each year, and let's just check that. Yeah, okay, so no, and then, I mean, this one should say what, it doesn't lose its leaves. Yeah, okay, right, it does not. Alright, so yeah, I think this seems to be working. Let's just go back just to make sure that we've done this right. Yeah, okay, so we've got this print trees. Alright, so I mean, here's where we want to actually use them then. The main program calls read data, stores the return value, and calls print trees with the first object in the returned array. Okay, so right, okay, this one. Right, of course, well, what we can do, I mean, yeah, we can just really delete this. So what it's then, okay, basically then we want to create an array of all these trees. So let's just do like we've done before, right? Well, tree array, right? Let's call that trees, and that's going to be equal to reads data. Right, then it said what we just want to call the print trees, I think, on the first element. Yeah, okay. So then if we just go print trees, and right, that's going to be trees, and then yeah, just index 0. Yeah, okay, and again, obviously, well, just copy that code, test the program, take a screenshot. Yeah, and I think, yeah, I'm pretty sure we've done everything there. Okay, then it says the procedure choose tree takes an array of tree objects as a parameter. The procedure prompts the user to input their requirements for a tree. The user needs to enter the maximum height the tree can be in centimeters, or maximum width, and whether the tree should be evergreen or not evergreen. A tree meets the requirements if the tree's maximum height is not more than the user's input. So when we say not more, well, that means less than or equal to. Right. Also, the tree's width again should be less than or equal to the sort of maximum width that they input here. And well, yeah, the tree matches their evergreen input. The procedure creates a new array of all the tree objects that meets the requirements. Right, okay. The procedure calls print trees for each tree object that meets all the requirements. If there are no trees that meet the requirements, a suitable message is output. Alright, so I'm just going to actually have a look at how they've done this in the mark scheme, because, I mean, of course, you could have it where you just create an array of size 9, and then, let's say if the trees don't match, you just store it as null. I mean, you could also use, for example, again, like in Java, you can use an array list, but since that's not on the syllabus, I mean, that's probably not what they want you to use. Okay, so I just checked the mark scheme, and well, they did what I thought, where they just create an array, bigger than what we need. And for some reason they make it 20 elements. So I guess maybe because they're saying, the file might get bigger at some point. Yeah, even though currently there's only 9 trees. And I guess that, well, if a tree doesn't match the criteria, then of course, well, the array is just not going to be full, right? There's going to be some like null values in there. So yeah, I think, let's just try and code that up then. And yeah, let's just minimize that. And actually, yeah, well, one thing I did forget actually is if we look at this, well, read data, I think we do also just want to close this buffered reader. So, okay, right, if we go, yeah, br.close, just like that. Although, to be honest, in Java, the garbage collector should handle that as well. Right, so let's go, right, public static, and yeah, actually, wait, what was the name for this? Right, choose tree. Yeah, right, it's going to be a procedure. Right, so since it's a procedure, well, let's go void, right, then choose tree. And yeah, let me just copy, right, some of those instructions. I think, okay, right, so it takes an array of tree objects as a parameter. So again, well, just like we did for the other one, let's go tree, this will be trees. Right, then we just want to ask them, so we want to ask them the height, the width, and the, yeah, evergreen or not. Okay, so we could, pre-declare these if we want, although, yeah, we don't really have to. Right, so I'm just going to go scanner, and, well, like we've done before, let's go scanner, right, that's, yeah, new scanner, right, then, well, system.in. Right, let's say, I know, yeah, like, enter max height of tree. Right, then what we can do, well, let's go int, let's go max height, and that's going to be equal to, well, scanner, and, yeah, next int. And then notice, because this is only going to look for integers, well, then we don't actually have to, well, okay, we don't have to convert this, right, using your integer.parseInt. And yeah, okay, just quickly, so this is another thing, like, if you think, well, how do I convert, let's say, a double to a string, or how do I convert, a string to a double? Well, let's say, for example, you want a double, right, if you just type double in, well, big letter, right, then if you do the dot, well, of course, yeah, here we're going to see all of the methods. And then, you're going to have, well, toString, right? You can also have, well, parse double. So that's, if we see here, well, that's going to take a string parameter and, yeah, obviously return a double. So again, just use the class names, and then that's going to give you, yeah, all of the attributes, right? All of the methods that you can use. All right, and then, well, I'm just going to copy that because, basically it's going to be the same. Right, so the next one, I guess, well, this should be max width, and yeah, let's change this just to max width, and then the last one, right, evergreen or not evergreen. And right, let's go, yeah, should tree be evergreen? And I think, well, we can just go yes or no. I think that's the input they want. Yeah, okay, right, so here it doesn't tell us. But if we look in the file, what we saw that it's going to be big Y and then big N. So I think, yeah, we can just, ask for that as well. Yeah, okay. Right, so that's going to be evergreen. And then, right, I suppose, well, here then this is going to be a string. Yeah, and then, well, okay, so obviously, well, rather than next int, again, we can just see, and it's going to be next line. So yeah, next line will return a string. Now, like, well, if you wanted, you could be a little bit more, yeah, I don't really know the word. Let's say, okay, you could allow them to enter, sort of lowercase and uppercase. So I suppose probably, let's say, more lenient in terms of their input. So let's do like evergreen, and maybe evergreen string. And then what we can do, well, let's have a Boolean, and we can just call it is evergreen. Now, if you want, you could use something called the ternary operator. So what we can do, let's go evergreen string, right, and hang on. Right, if we just go equals, right, that's going to be evergreen string, right, 2 lowercase. And then I guess we just go, yeah, okay, right, then we go equals. Right, and we just say, well, if this equals yes, right, and okay, yeah, so actually, well, we actually don't need an if statement in this case, because what we're saying is, well, if it, yeah, if it does equal lowercase yes, of course, well, then evergreen is true. All right, well, if it doesn't equal if it doesn't equal lowercase yes, well, then we say evergreen is false. Now, here they don't ask for any validation because, of course, if they type in like ABC, well, ABC is also going to say evergreen false. But I mean, yeah, like here they don't need any validation, so I think it should probably be okay. Although if you wanted, I mean, you could also have an error message. Yeah, just checking that they enter valid input. Right, so what we want to do then, I mean, obviously we want to loop through all the trees and just check these conditions. And yeah, let's also make this tree array that they mention. So let's go tree, I mean, let's say like valid trees, I guess. And right, let's go, new tree array. And I suppose here, I mean, we can just give it, I mean, well, let's just give it a size of 9 since they said, well, there's 9 trees in the array. Right, therefore, of course, there can never be more than 9. Let's also go int, maybe let's go valid index, and that'll be 0. Right then, in order to loop through, okay, so I mean, again, you know, you could just use the enhanced for loop. I think I'm just going to use a regular for loop in this case. I mean, let's go index, right, that can be 0. And what we'll then do is, well, we're going to loop while, okay, right, we're going to loop while the index is less than, and that'll be trees.length. Right, then if we just go index plus plus, right, just to increment that. Right, then what we want to do, well, we just want to do this if statement. So, right, let's check if the right trees, yeah, so trees index, and then what's going to be the get max height. Well, if this is less than or equal to the max height, I think, yeah, is that correct? Alright, tree's maximum height is not more than the user's input. Yeah, therefore it should be less than or equal to the user's input. Yeah, so I think that's fine. Right, well then we just want to do and, so this will be trees index, right, the get max width. Right, and then that should be, yeah, less than or equal to the max width. Right, and then, yeah, so we want to say and the evergreen. Okay, alright, so I realised, yeah, we actually didn't, yeah, I think we didn't actually need this one here. I mean, what we want to do, we basically want to check if their evergreen string, and again, I mean, I think let's convert that to lowercase, it's fine. You know, just check if that equals to the, tree index, you know, get evergreen. Yeah, so let's do that. So, right, yeah, I'm just going to call this evergreen, right, not the evergreen string, and I'm just going to delete this. Right, so we say, yeah, evergreen, right, 2 lowercase equals, and this is going to be the trees index. Right, and then that's going to be, yeah, right, okay, get evergreen. And then here, you know, we also want to convert this to lowercase. Because of course, if we've converted this to lowercase, yeah, therefore we have to also convert this to lowercase, right? I mean, yeah, otherwise they're going to be different. Okay, right then, I mean, if it is true, it says we want to add this to the valid trees. So let's go valid trees, right, index, and that's going to be equal to, and then trees, yeah, index. I think then it said we also want to print. So if we go print trees, and then just print this trees index. And yeah, was there anything else we need to do? Right, yeah, if there are no trees that meet the requirements, a suitable messages output. So I guess what we need to do, we also need to increment this valid index. And I think actually this shouldn't be valid trees, right? This should actually be the valid index. Yeah, okay. And then right here, let's just go the valid index plus plus. Because, I mean, of course, what you could have is, let's say this might be 5. But, you know, if this is the first valid one, well, then the valid index should still be 0. Which, yeah, of course, that's what we want. Right, so yeah, we increment the valid index, and then I guess at the end we can just check if the valid index is equal to 0. What would you say, S outright, like no valid trees? Yeah, I think that's fine, and then I guess the next one is probably about testing it. If we see, then this next question is actually completely different, okay, it's not about testing. So what I'm going to do, I'm going to go back and just test it, okay, make sure it's working. Right, so I guess, rather than print trees, I'm going to comment this out just temporarily. Right, then let's go choose tree. That's going to take in this trees. Right, so well, I mean, yeah, obviously we're taking in these trees that we've read from the file. Right, then let's just run this. And right, enter max height. Now, yeah, if we go to this, I don't know, maybe let's try and select this holly. So if we go max height, well, let's try, for example, 700. Right, the max width, I mean, let's just try 400. Okay, right, so I mean, here actually, like, maybe you can't tell, but I actually didn't type anything in there. And I think the reason it's done that is a bit weird. Like, what this is going to do, well, this is just going to get the next integer, right? Of course, this just gets, the next integer. But I mean, since we pressed enter, there's also going to be a new line character. So yeah, I don't know, like maybe if we just s out evergreen, see what this actually prints. So again, I don't know, let's go, what, 700, maybe 350. Yeah, so I guess it's just printing out this like empty line. Because there's an extra, I guess there's like an empty new line right after yeah, I don't know, like after I, pressed enter here or something. So I think what we can do, if we just go scanner, right, then next line, and if we do that before we then, ask them to enter the new line, yeah, that should then just kind of, let's say, like eliminate all the new line characters that they've sort of like currently entered. Yeah, I'm not sure if that makes sense. I mean, if you actually look in the mark scheme, like rather than using next int, what they actually do is, well, they just always use next line, and then if we see here, it's going to tell us we need to convert it. So then we can just wrap using parse int, and I guess in some ways that's easier because, well, then it's going to read the whole line, right? You're not going to have this situation where, yeah, we have like half of the line that's being read, well, obviously, yeah, just the integer part, and then let's say the actual new line character at the end hasn't been read. Yeah, so I think that was the problem I was getting. Alright, but I'm just going to keep it like this, and I think this extra new line should fix it. So let's run it again, see if this works. And then yeah, if we just go back here, so we said let's go 700, because that's going to be bigger than, bigger than the max height of this. Yeah, hang on, let me just see. Yeah, okay. Yeah, so I think that's the correct logic. Right, then let's choose like 400, so it should be bigger than the actual width of the tree. And then right, if we just go yes. Yeah, I mean, I don't know, like that seems like a lot. So it's saying, well, holly does not lose its leaves. I mean, yeah, that's correct. So how about this one, right, magnolia? So, right, magnolia 500 and then 300. I mean, yeah, that seems okay. This photinia, yeah, I mean, that also seems okay. Right, blue conifer, I mean, yeah, okay, that's smaller. Right, so I mean, let's try and choose some smaller values, because otherwise, I mean, that's just way too many. Right, so let's try like maybe 300, and then I mean, yeah, this should only get, for example, some of these. And let's try here, maybe go 150, and again, let's just go yes. Yeah, okay, right, then in that case, that only gets these. So I think this seems to be okay. And then if we go to the next one, where it says the procedure choose tree needs amending, after the procedure has output the list of trees that meet all the requirements, the procedure needs to take as input the name of one of the trees that the user would like to buy, right, that meet all those requirements, and takes as input the height of the tree in centimeters when it is bought. Right, it will then calculate an output how many years it takes for the tree to grow to its maximum height. For example, the user enters the tree beech, the tree's height is 40 centimeters when bought. The tree will take 12 years to reach its maximum height of 400 centimeters. Okay, I mean, so well, let's just check the calculation here then. In order to calculate how many years it will take to grow to that height then, I suppose what we want to do, we want to take the the maximum height. So if we look at, say, I don't know, maybe this, yeah, okay, well, sorry, right, let's look at this beech, right, that's the example they gave. So let's say, well, 400, right, then we want to go minus the starting height, which is 40, right, then we just divide it by the amount it grows each year, and then, yeah, if we do that, well, that, that should then equal 12, yeah, which is what they told us. Alright, so let's try and just implement this, and I suppose what we can do, well, if the valid index equals 0, of course, well, this means no valid trees, right, therefore we can just have an else, of course, well, this means there are valid trees. And then what we want to do, we just want to loop through this valid trees. Yeah, okay, so right, let's do that then. And I suppose I mean probably, right, hang on, yeah, I thought I copied that, maybe not. I mean, well, let's just see the instructions. Right, we want to take as input the name of one of the trees that the user would like to buy. Okay, so let's give them a message, and we'll just say, well, enter, yeah, name of tree to buy, or yeah, type of tree to buy. Right, let's call this, I don't know, like, well, tree name, I think that should be fine, or yeah, tree choice. Right, then that's going to be scanner, and then, well, next line, right, since it's a string. Right, then we just want to loop through and, you know, find the tree that's equal to that name. Right, well, yeah, of course, if there is one. So, right, let's go int, we'll say index, and, right, this will be 0. And then what we want to say, well, we want to loop, well, from 0, and of course, what, while it's less than the valid index. Yeah, okay, right, then if we just go index plus plus. And I guess what we can then do, well, let's just check. And okay, this time, you know, don't make the mistake of using this trees array. We actually just want, like, we only want to, you know, select from the valid trees. Yeah, otherwise the index numbers are going to be wrong. So right, if, well, valid trees index, and let's go equals, and we want to check, what does that equal the tree name? Right then, if it does, I guess we then want to ask for the height. So let's go, I know, yeah, enter, right, height of tree when bought. And then, right, let's make an integer variable, and we can just go, I don't know, well, let's say, right, height, yeah, when, I don't know, height bought or height when bought, right, it doesn't really matter. And then here, well, that's going to be scanner, right, and then it's going to be next int. And then, yeah, I suppose, I mean, here then we just want to do our calculation. So I think I'm going to make another variable. I mean, let's say, like, I don't know, years to reach height. And then the way, okay, right, and well, again, the way we calculate that then, right, it's going to be the valid, okay, right, hang the valid trees, right, then it's going to be the current index. And what we said, this is the get, yeah, the get max height. Right, then we want to subtract the current height, so that's the height bought. Right, then we just want to divide it by, well, again, that's going to be valid trees. Right, index, and then this will be what the, yeah, okay, right, this one, right, get height growth, because, well, that's how much it grows each year. And then I think let's have a message for this, let's say, I don't know, yeah, maybe it will take, let's go, like, years to reach height. Or let's say years, yeah, to reach, and then I think I'm just going to have, yeah, I mean, let's say, you know, like, well, like 400 centimeters, right? Well, that was the one in the example. And yeah, let's just go CM like that. Okay, so I think that should be okay. And what's this saying? Right, inconvertible types tree and string. Okay, so yeah, that's because here then I forgot this should be get tree name. And again, you know, this is the advantage of, let's say, using something like IntelliJ. Yeah, obviously it's quite good with the sort of error suggestions, or yeah, like error, yeah, error messages. Okay, yeah, so well, if we just run this then, and let's try and use the example they did. So what they said, beach. So right, enter the max height. Well, let's go, what, like 400. Yeah, that should be okay. Right, the max width, let's say 200. Right here then it should be no, because, well, if we're looking at this beach. Right, the name of the tree, well, that's going to be beach. Right, the height of the tree when bought, I think they said 40. And then, yeah, here it says it will take 12 years to reach 400 centimeters. Alright, so I think this is fine. Right, then we want to write program code to amend the main program to call choose trees, test your program with the following tree requirements, right, maximum height of 400, right, maximum width of 200, tree evergreen. Right, and then, right, blue conifer, starting height 100. So, well, I'm just going to copy that. I mean, let's see if it works. And to be honest, like, right, hang, wait, question 2. Yeah, I suppose, you know, they also want us to have this one as well. So, like, if you do make changes, I mean, make sure to actually have the original as well. Or, okay, well, yeah, make sure to have, you know, the code from the previous questions, right? That's what I mean. Right then, well, okay, yeah, let's just run this. And I'm just going to, yeah, let's just paste these here, right, just so we can see. Right, so max height, that's going to be 400, width 200. Right, tree that is evergreen, so that should be yes. And right, then we want to say blue conifer. Right, and then the height, okay, that's going to be 100. Right, so it will take 3 years to reach 250 centimeters. Yeah, I mean, so is that correct? Because, well, let's have a look at the data. Right, so blue conifer, that grows at 40 per year. Yeah, okay, yeah, this is the, right. So if it starts at 100, see, I mean, right, like this is the thing, because, I mean, if it's 3 years, then, well, I mean, that's only going to get to 220 centimeters, right? It's not going to reach 250, because I guess what technically this would be like 3.75. Now, I was thinking about this, you know, should we round up, should we round down? So I think, yeah, maybe they would want us to round up, right? Because if it's like 3.75 years, probably they would want us to say 4 years. I mean, like, or we could have it where if instead of making this a integer, right, if we make this a double, and then I guess we would also have to cast this into a double as well. So now, I mean, now what this is saying is this, well, I mean, it's going to do this calculation, right? But, you know, then it's going to convert it to a double, or well, it's going to cast it to a double. Yeah, then if we do, well, a double, right, divided by an integer, that should give us a double answer. So yeah, I mean, let's try again. Right, so the height, well, that's going to be 400, right, width 200, right, this is going to be yes, right, so this is blue conifer. Right, and then the height 100, and then yeah, 3.75. So I mean, I think that's probably okay. Yeah, they should accept that. The last question says a program reads data from the user and stores the data that is valid in a linear queue. The queue stores the global 1D array queue data of string values. The array needs space for 20 elements. The global variable queue head stores the index of the first element in the queue. Alright, queue tail, or last element. The main program initialized all the elements in queue data to a suitable null value, right? Queue head to -1 and queue tail to 1. Okay, right, so just write program code for the main program, and your program should be called question 3, right, June 24. Okay, so let's just go ahead and do this then. Right, let's go new file. Right, so question 3, right, J24, and yeah, I'm just going to minimize that. And again, let's just zoom in a bit. Right, so alright, so as we've done before, well, if we just go main, that's going to create it. And I think, right, I'm just going to copy these instructions here. Right, so first and then we want these global variables, right, queue head, and I guess we're also, yeah, this queue data. So as we saw, well, if we want a global variable, we're going to have to use static because, well, you know, this main is static. Right, so let's go queue data, and hang on, right, so yeah, this should be a string array. Right, and then what we can do, well, let's go, yeah, equals, right, that's going to be new string, and let's say 20, right, so well, a new string array with 20 elements. Okay, right, then global variable queue head, so this is going to be an int, and again, hang on, right, yeah, let's also make this static, right, so static int, right, queue head, and that's going to be, right, -1, yeah, okay. Right, so yeah, hang on, right, that's going to be -1, and let's also go queue tail. Okay, right, that's also equal to -1. Yeah, if I can type properly. Alright, so actually it says, well, the main program will initialize, so I guess we can also do that in here as well. So if we want to initialize queue data to be, well, let's say suitable null values, I mean, you could use an empty string as a null value, but that's probably not the best because, I mean, well, obviously an empty string is also a valid string, and like, I don't know, maybe if you're storing, for example, maybe like sort of middle names or something. Of course, you know, some people, they only have a first name and a last name, right? They're not going to have a middle name. Yeah, therefore, like, well, obviously, yeah, just an empty string would be valid. So I think instead I'm just going to use null, right? So let's just loop through all of these. Let's go, what, int x, or yeah, int n. Right, that's going to be x. I guess what we can say, what, queue data dot length. I mean, of course, we could also just use less than 20. That's also fine. Right, and then what I'm going to do, let's go queue data, right, at index x, and let's just assign that null. Right then, yeah, what is that saying? Okay, right, so it can be replaced with a single arrays.fill. Now, I mean, of course, like you can do this. However, I would say in the exam, probably don't go using any of this, like advanced stuff. Yeah, just go, just use like simple for loops, right? Don't go using any, libraries or, yeah, any sort of, one-line functions or one-line methods. Right, then we just want to go queue head, and yeah, that's -1, and then well, queue tail. Right, let's also assign that -1. Yeah, okay, so I think for that one that's fine then. Right, then the function, well, enqueue takes the data to insert into the queue as a parameter. If the queue is not full, it inserts the parameter into the queue, right, updates the appropriate pointers, right, and returns true. If the queue is full, then it returns false. Okay, write program code for enqueue. Right, let's just quickly recap a queue then, and we'll try to just sort of, do this on paper. So if we say what the head, that's going to start at -1, also the tail, that also starts at -1. And I mean, well, let's say here this is our queue. Now, let's say when we enqueue something, so let's say A. Now, what's going to happen then? Of course, well, our head is going to go to 0 because, well, now this is the first element in the queue. Rather than if we think, well, our tail is also going to go to 0 in this case. Right now, I mean, now let's say we add B, or if we, enqueue B. Well, here then the head is going to stay at 0, but then in this case, well, the tail is going to go to 1. Right, of course, then if we have C, well, of course, well, the tail is now going to become 2. So what we're saying is, well, if the head is -1, right, then, well, yeah, the head of -1 should go to 0, and then, well, the tail, I mean, this is just going to increment every time. I mean, well, okay, right, so let's think then, like, let's imagine if we only have a queue of like 3 elements. So yeah, let's just say, we don't have that. Well, like when we can tell it's full is we can say, well, if the tail is the size of the array -1, because like in this case, well, if the tail is 2, right, of course, well, that means, yeah, we filled up the array, because again, this is what elements 0, 1, and 2. So yeah, I mean, well, let's see if we can code this. And yeah, I'm just going to delete these comments. Right, so if we go public, yeah, public static, and then actually I think they said this is a function, right, it's going to return a boolean. Yeah, let me just, yeah, okay, right, so it takes a parameter, and here they actually don't tell us the parameter name, so yeah, I guess we can call it anything. Right, okay, so let's go, yeah, enqueue, and probably let's just call this data, right, of course that's going to be a string parameter. I mean, first we can probably check, well, if the tail is equal to 19, because again, they said the queue size is 20, so if it's 19, it's full. Right, so if right, queue tail, right, is equal to 19, well, then we can just return false. Right, else, so, oh no, I suppose we can also, yeah, well, I mean, okay, like really we don't even need this else, right, because obviously, well, if it returns false, well, like then, okay, well, obviously if it continues, right, then of course it must be an else. So, I mean, let's have another if, and we can probably go, what if the queue head, right, so if queue head is equal to -1, well, then we're just going to set queue head to be 1, okay, sorry, queue head to be 0. Right, then what we want to do, well, we just want to increment the, right, okay, yeah, let's go queue tail, let's just increment that. And what we're then going to do, well, we're just going to insert the data in that position. So, right, okay, that's queue data. Right, then we go, yeah, queue tail. And right, that's going to be equal to data. Right, and yeah, is there anything else we need to do? And I guess, right, just returns true. Yeah, so I think that should be okay. Now, what I'm going to do, actually, I'm just going to test it just with, well, 3 elements like we saw. Okay, so let's make that 2. Right, just so we can test it quickly. And right, let's go S out, we'll just go, right, enqueue, and let's just go A, for example. Right, yeah, well, let's try, well, just A, B, C. And then let's also try and have a 4th element as well. And what I'm going to do, I'm just going to do S out, and let's go, well, as we saw, right, arrays to string. And then, right, that's going to be queue data. Yeah, just so we can, quickly see these results. Yeah, okay, right, so here then we've got, what, 3 success, right, and then, yeah, 1 fail, right, 1 false at the end. Yeah, no, I'm just going to undo all of this because, well, we want to go back to our size of 20. Okay. Right, then the next one, the function dequeue returns false if the queue is empty. If the queue is not empty, it returns the next item in the queue and updates the appropriate pointers. Okay, so let's go and think what happens then. I mean, first, what if they try to dequeue when it's empty? So if they try to dequeue and the head is -1, well, then we should just return false, or yeah, return an error, whatever they wanted, I can't remember. Likewise, I mean, well, let's say if it's a valid dequeue. So like we have here, we have obviously, well, 0, 1, 2, right, A, B, and C. Now, if we dequeue, right, that's going to be, well, dequeuing A. Right, then our head pointer is going to go to 1. Right, then we dequeue B, so our head pointer goes to 2. And then I guess, I mean, this one is still valid, right, if it's 2. Yeah, so, well, then, you know, that's going to become 3. But then if we have a situation like this where the head pointer is greater than the tail pointer, well, that's going to be invalid. You know, we're not going to be able to dequeue in that case. So yeah, that can be also another situation where we return false. And I suppose, you know, you could also check what if the head pointer is greater than, yeah, if it's greater than 19. Although you probably shouldn't really need to check that because, well, actually the head pointer, yeah, the head pointer should never be able to become greater than 19. Because, well, we say this one can never become, 20, yeah, okay, this one can never become 20. Therefore, if this can never become 20, well, then we would never be able to increment this. Yeah, because of the check that we're doing that, you know, the tail pointer has to be bigger than the head pointer. So let's just try and code this then. We want to go public static. And I think they actually said it's going to be a string, not a boolean. Because if we look, right, it's going to return false as a string. Okay, not the boolean false. So right, let's go dequeue. Right, and then, well, here we don't need any parameters. And let's just try and think of the invalid cases, so when we want to return false. Right, so one is going to be what if the queue head is equal to -1. Right, I think then we can have an or. And this will be what if the queue head is greater than the queue tail. Yeah, I think that should be another one. Yeah, I mean, alright, so I mean what I'm going to do, you know, I'm just going to test this, but yeah, I think it should be like that. Right, and then here we just want to go, well, return false. Right, then, yeah, I mean, here we can have an else, although again, we don't really need it. Right, so here, well, if it's a valid dequeue, well, then we just want to increment the queue head. And yeah, let's think, because I think we're going to need a variable to store the current item. And then, yeah, once we've got that current item, then we can increment the queue head, right? Then we can return the item. Yeah, okay, so it's going to have to be like that. So, right, let's go string, I mean, maybe item or data. Right, that's going to be the queue data. Right, that's going to be what the current queue head. And then we just go return item. Yeah, okay, so I think that should be alright. And then, I mean, let's just test it, see if this works. So probably I should have actually kept those. Yeah, let's go here 3. And right, let's also go 2. Right, so let's go S out, and again, we'll just enqueue. Let's go A. And yeah, let's just copy that. Alright, and then I think, I mean, first actually, well, let's just test it when it's empty. It should just say false. Right, so if we go dequeue, yeah, right, so well, dequeue of an empty queue, right, should return false. Yeah, okay, right, so that seems to work. I mean, now let's try with these 3. So, right, then what we can do, maybe let's just copy this one again. Yeah, and I mean, I think this should be okay, although, like, we can't really just do, you know, to print the array, because, well, obviously it's the pointers that have changed. So let's go S out, and then we want to go what queue head. And I think I'm just also going to output this queue head before this dequeue. Yeah, let's test that, see if it seems to work. Yeah, so I guess what it's gonna, the queue head is going to be 0, right? Then it's going to be, well, then it's going to dequeue, right? Then it's going to increment, right, to 1, as we can see here. Let's try calling this like 3 times. Or I suppose, well, 4 times. Yeah, that should be okay. Because obviously, well, I mean, the first 3 should be valid, right? Then the 4th one should be invalid. Yeah, okay, so right, we get ABC, right, then we get false, because I guess now the queue head is greater than the queue tail. Right, so yeah, I think this one seems to be working. And again, I'm just going to make sure, let's set that back to 20, and yeah, let's set this to 19. Right, then the next it says the string values to be stored in the queue are 7 characters long. The first 6 characters are digits, and the 7th character is a check digit. Right, the check digit is calculated from the first 6 digits using this algorithm. Right, multiply the digits in position, well, 0, 2, and 4 by 1. So if we look basically the right, even indexes. Right, multiply the digits in position, well, 1, 3, and 5 by 3. Then calculate the sum of products, or add together the results from all multiplications. Divide the sum of products by 10 and round the result down to the nearest integer to give the check digit. Right, if the check digit equals 10, then it's replaced with x. Okay, so yeah, right here then they have what they do, what 0 times 0, okay, sorry, yeah, right, 9 times 1 is 9, right, 5 times 3, 15. Of course, they sum all of those up. Right, they divide by 10, then round down. Right, and then check digit 4 is going to be in character 6, which I guess, yeah, they don't show us on this one. But yeah, that's just going to be in this 6th column. Yeah, which I guess what they just show us in this final output. Right, then it says a 7-character string is valid if the 7th character matches the check digit for that data. Right, so yeah, so I guess what 3, 5 is invalid because, yeah, 7th character 5 does not match the check digit, which is going to be 4. Right, subroutine store items takes 10 7-character strings as inputs from the user and uses the check digit to validate each input. Right, each valid input has the check digit removed and is stored in the queue using enqueue. Right, and appropriate messages output if the item is inserted, and appropriate messages output if the queue is already full. Right, invalid inputs are not stored in the queue. The subroutine counts and outputs the number of invalid items that were entered. Right, store items can be a procedure or function as appropriate. Right, and then yeah, we just want to write this. So I mean, actually, like, this seems like super long for only 6 marks. I mean, this is what, over. Yeah, I mean, so okay, right. I mean, well, basically, it's a whole page, right? Just this one question. So I guess what first then we just want to calculate the. Yeah, okay. So what I guess we're going to want a loop, because we're going to want to loop 10 times, and then inside that loop we're going to have to validate. Yeah, I think that's what they want us to do. Right, okay, so let's just try and do this. And it says what we can create either a procedure or a function, and since it didn't say we need to return anything, I mean, let's just make it a procedure. So right, let's go void. Yeah, since it's a procedure, this will be store items. I think it had no parameters. Yeah, because it's just taking those inputs. Alright, so again, well, let's just go scanner. Right, let's go SC. That's going to be a new scanner. Again, that's going to take system in as a parameter. Right, then if we just loop, so let's go int x. Right, that can be 0. Yeah, I mean, or we can call it index. Right, let's go what index is less than 10. Right, then, well, just increment index like that. And what we want to do then, we want to get what the, I guess what the current code, I mean, yeah, what do they call it? Yeah, I mean, I guess just like data, I think that's fine. Right, so let's go, okay, data, and that's going to be what sc.next line. Right, I suppose then we want to calculate, yeah, I mean, then we just want to calculate the check digit. So in order to do that, well, then we just want, going to want another loop. Right, obviously, let's say, well, from, 0 to 5. Now there's actually a few ways you can do it. I mean, either you can do, well, 0 to 5, and then you can check if it's odd or even. And you can check if it's odd or even using like mod 2. So yeah, let's try and do that, see if this works. Okay, so right, let's have 4, and here, I mean, we can say what the sort of check digit index. Let's maybe like, yeah, I know, like char index. I think that's okay. Right, then what we want to do, so right, we want to get what char index, and that should be what less than, yeah, I suppose what, well, less than or equal to 5. I mean, we can also just go less than 6. And let's go what char index plus plus. Okay, right, now then we want to get the current character. So yeah, I mean, I think, yeah, okay, so I think, well, let's go char. Right, then if we go, well, current character, then what we can say, that's going to be, well, the data. Right, then, I mean, then, yeah, okay, so here we can just do char at, and here then it's going to be, well, the char at the char index. And then we want to think, well, how do we actually convert that into a number? Now, I mean, like, we can do it just using, you know, plus 48, because, well, we know that whatever the ASCII is, if we then, okay, no, sorry, right, minus 48, because, for example, well, let's say 0, right, well, 0 is going to be 48 in ASCII, right, therefore, of course, yeah, if we get the ASCII code, right, then we can, you know, just sort of minus 48 from that. So, well, no, I mean, let's try and demonstrate that if we go, yeah, so I mean, I think honestly we can just do current char minus 48. I mean, that should also work. And all right, let's go. Yeah, I think what I'm going to do then, let's just maybe, right, okay, so I think, yeah, this one we can delete. And then, right, this is going to be store items. And what I'm going to, I mean, I suppose we can keep it as 10, and then, yeah, I'll just, like, stop it. Alright, so I mean, I probably should have given them a message here. Let's go, like, maybe, yeah, enter, I don't know, like, yeah, enter code 1 or something. And right, what I'm also going to do, I'm going to do what index plus 1, right, just so it's, yeah, like code 1 rather than, you know, code 0. And let's say here, we'll just like 1, 2, 3, 4, 5, 6. And then, yeah, here, right, I mean, this does get these values. Because again, you know, just using this minus 48. And I think that there is probably another way where what we could do what string, yeah, I guess what we can do, like integer.parseInt, right? I think that should work. So right, can we go, yeah, integer, right, parseInt. I mean, right here it says it takes a string, but yeah, maybe we can just use a character. No, all right, so if we can't use a character, well, then we can just do, you know, character to string. So yeah, I guess we can do what string.value of character. Okay, that's going to return the string of that character. Alternatively, like, we could just make this a string, and yeah, rather than using char at, well, then we can just use substring. And right, let's get the begin index, and then what this is going to take, right, the end index. So I guess what the end index is going to be the, well, char index plus 1. And I think, yeah, this should also do the same. Yeah, okay, right, so this is also the same. Alright, so again, obviously there's kind of like, well, many different ways you can actually do this. I think, like, probably let's just use this method. And then this can be, I don't know, let's say like, I know it's like num, I guess. Right, and then, I mean, we want to think, like, if it's odd or even, and of course we're also going to need a sum here. Now, right, let's say if it's an odd index, so we can go, right, well, if char index, right, then mod, so that's going to be 2. Right, well, if this is equal to 0, I suppose, well, then we just multiply by 1. Yeah, okay, so multiplying by 1, I mean, effectively that's doing nothing. So then we can just go, right, sum, that's going to be equal to what, sum, and then what, plus num. Because it, well, I mean, of course you can do like num times 1, but again, you know, the times 1, yeah, as it's telling us, right, that's going to be redundant, so we can just simplify that. Right, then we can have an else, and here, well, let's go what sum equals, and that's going to be, was it num times 4 or times 3? Okay, alright, so times 3. Yeah, so I think this should work, and then if we just go s out, and let's go s out sum. Right, and then I'm just going to copy this one, you know, just to make sure this is working. Right, I mean 42, don't know, like, is that correct? Yeah, okay, right, 42. Now, I will actually show another way you can do it. Like, of course, you can just do it like this. Right, alternatively, rather than doing char index plus plus, you can go, right, char index, and then if we plus 2 each time. Because actually, sometimes they use this kind of method, let's say when reading from files. Like, if you want to, say, read, like, 4 lines from a file at one time, and then, yeah, you want to store those 4 lines, you know, as part of, I don't know, maybe as part of, like, one class, or, yeah, one, like, record. Yeah, or even one sort of, you know, 2D array kind of like row or something. Then what we can do is, let's go right sum, and well, so here then that's going to be right sum plus. Now I suppose actually right here then we'd actually need to get 2 characters. So to be honest, in this example, it's probably not actually the best way. So you say sort of, well, like, yeah, current char, well, you say probably next char. So the next char, well, that's going to be what the char index plus 1. Then it's going to be what the char index plus 2. So of course, I mean, this is just going to get the first. So like here where we have 9, 5, it's going to get both the 9 and the 5 kind of in one go. Right, so then what we can do, well, we say that the sum is just, well, the sum, right, plus the num. Because again, this is going to be the first character. And then, right, I'm just going to copy this. And then what we can do, well, let's say, right, rather than the current char, now we're going to get the next char, and we're going to go, num times 3. And I mean, actually, this one we don't need brackets because, well, the yeah, I guess the multiplier has higher precedence, but I'm going to put brackets just to be, you know, explicit. And then I think if we do that again, I mean, it should give us the same result. And yeah, okay, we also get 42. So hopefully this makes sense how it's working, right? I mean, this time we're only going to be looping 3 times effectively, but each time we're just getting, you know, 2 characters rather than 1. So yeah, well, obviously, you know, either method is okay. Right, then we want to divide the sum of products by 10. Okay, so if we just take the sum, of course, well, we can just divide that by 10. And let's probably make this an integer. We'll just call it check digit. Right, and then, yeah, we say this is inserted into character position 6. Okay, so... Right, wait, so hang on, like, are they giving us 7 characters to start with? Yeah, I don't know, I mean, like, I think sometimes the most difficult thing is actually just, like, reading and understanding the text. Right, so, yeah, the check digit is 4, this is inserted into character position 6. Right, a 7 character string is valid, right, if it matches that. Okay, alright, so yeah, the subroutine takes 7 character strings as input. Right, each valid input has the check digit removed and is stored in the queue using enqueue. Okay, right, so well, let's check if it's valid then. So the way we check if it's valid is we see, well, if the check digit is equal to, and then, well, that's going to be to the 6th character. So we want to go... right, this is going to be, yeah, what do we call that? Right, data, and yeah, let's again just minimize this. So right, if data, and I guess, I mean, again, we could do char at, we could also just do substring, and then substring, well, here we can just go 6, all right, and then, yeah, that should just get 1. And can we go, yeah, like if we try 6, 7. I mean, let me just test that quickly. Yeah, okay, well, alright, so here it's saying it can be replaced with char at, since we're just getting 1 character. But again, I mean, let's just test it, alright, just to check that that's actually getting the correct character. Right, so in this case then it should just output 4. Yeah, okay, that outputs 4, right, so that's fine. But then I mean, we want to think that, of course, well, this is a string. So we then want to do equals, right? But then this check digit is going to be an integer. So we just want to convert the check digit. Well, I suppose we can do either, right? Either we can convert, this substring into an integer, right? Or we can convert the check digit into a string. So to convert the check digit into a string, what we can do, I guess, well, just write integer, yeah, then toString. Of course, yeah, that can work. But I think here, let's actually just do parseInt. So integer dot parseInt. Right, hang on. Yeah, then let's check that that's equal to check digit. Right, then if it is, yeah, let's see, what does it say we have to do if it is equal? So I guess if it is, then it's gonna have the check digit removed and is stored in the queue using onqueue. Okay, so let's remove it then. So we can just go data, and right, that's going to be data dot substring, and here we're going to begin at 0. Right, then we're going to I guess we're going to end at 5 probably. Yeah, I think that should work. Right, I'm also just going to s out the data, right, just to check I've not made a mistake. Right, then we're just going to enqueue it, and write an appropriate message output if the item is inserted, and appropriate message output if the queue is already full. Okay, because if we look here, so queue is going to return a boolean. Yeah, okay, so here then let's just go if, and right, let's go enqueue. Right, this is going to be data. So if this is true, what then? Right, yeah, okay, then we just have a message. So let's go s out, and we'll just go data, and then let's go, I don't know, was inserted, yeah, into queue, or okay, well, let's say, yeah, was enqueued. Okay, right, then we can just have an else. Let's go s out, I don't know, yeah, queue already full. Yeah, is that all we need to do? Right, invalid inputs are not stored in the queue. Yeah, I think that's fine. Right, subroutine counts and outputs the number of invalid items that were entered. Okay, so right, where are we checking if it's invalid? Okay, right, so I'm not sure why I have this system out print line. Okay, that should be an if statement. Yeah, and then I guess here then it's going to be this else. And of course we're also going to need, yeah, we're going to need a count. So right, because of course, this is going to be a count for all 10 items. So yeah, okay. So basically, we need to make sure we declare this outside of the for loop. Otherwise, it's going to be reset to 0 each side of the for loop. Let's just say invalid count. Right, that's going to be 0. And let's go invalid count and then plus plus. And right, where does the for loop end? Right, so the for loop ends here, then let's go s out, and yeah, let's have the semicolon. And then what it says, just output, yeah, the number of invalid items that were entered. So I guess we could have an if statement. We could say, if invalid count equals 0, no invalid items were entered. But I think, let's just do it like this. Let's say invalid count, yeah, let's say, right, items were invalid. I think that's fine. So it'll be 2 items were invalid. Right, and then let's try and run this. And then I think maybe the last question is just okay, alright, so yeah, okay, so let's try this next one. So we want to call store items because we can sort of test it here. Right, then call dequeue. Right, we want to output a suitable message if the queue was empty. Right, and output the return value if the queue was not empty. Okay. Yeah, this is a bit annoying because honestly having to write in 10 inputs is it's going to take quite a long time. So let's just make that 3, and I don't think I need to change that anywhere else, because this 10 here is not related to the number of items. This is basically just the sort of calculation for the check digit. Right. Okay. So yeah, what do we want to do then? So call store items, then call dequeue. Okay, right, so yeah, store items we've got, right, then let's go dequeue, and we want to check what if this is equal to false, because, well, if it returns false, then of course that means it's, well, that means it's empty. I mean, either empty, right, or it's, yeah, I mean, or we've got some error like this, but I think, I mean, we're really just checking if it's empty. Okay, so let's just go if, and that's going to be what dequeue, right, if this is equal to false. I mean, then we can say what, yeah, queue was empty. Yeah, I think that's fine. Right, I mean, else, wait, do we want to say what would actually, okay, right, yeah, output the return value if the queue was not empty. Alright, so actually here then we'll actually need to store this. Right, let's go string, and, well, let's call it item. Right, that's going to be, well, the return value of dequeue, and then we're just going to go, right, item dot equals false. Right, else, well, let's get s out, and I guess we'll just say maybe item, let's say, yeah, was dequeued. Yeah, I think that should be okay. Right, and then I think actually they do have some valid, yeah, okay, I mean, they do have some valid inputs here. Well, yeah, some are probably invalid as well. So what I'm going to do, I'm going to paste those here, and I do notice actually they also have this x. So I suppose, yeah, we can't really use like integer.parseInt. I mean, that's going to have an error. Yeah, I mean, let's run this then. So enter code 1. I mean, I don't know, let's try like 7 ones. Like, probably that's going to be invalid. No, I mean, it says that's valid. Okay, so this is wrong then. Right, here we want to go from 0 to 6, right, rather than 0 to 5. And I don't know, like, is that really valid? So if, yeah, I don't know, like, if we try and do that calculation, so 1 times 1, right, plus 1 times 3, plus 1 times 1. Yeah, I mean, so what's that going to be? It's going to be, right, 4, and then plus another 4, right, plus another 4. I mean, so that should just be 12, I think. Yeah, so I'm pretty sure that's going to be wrong. I mean, don't know, well, let's try it again. Alright, I mean, yeah, so why is that enqueued? Let's output the check digit. And then, right, I guess we can also probably output the sum. I mean, like, alternatively, you know, we could just add a breakpoint here, I guess. So, yeah, let's add a breakpoint maybe on this line, and let's just run this in debug mode. Yeah, okay, right, let's just allow that. Alright, and then let's type in again. Okay, so here then, right, the sum is 12, the check digit is 1. Okay, alright, so yeah, actually, right, this is why I'm getting confused, because, I mean, usually check digit uses modulus, but I think here is it. Yeah, okay, so here it's just using the, you know, I guess what div, right, it's not using modulus. Alright, so yeah, I think this is actually working correctly. Alright, so, well, let's try and run it again, right, just in normal mode. And we can probably just remove that print line data. Right, so if we just go like all ones. Okay, right, so yeah, that should be enqueued. Let's try again, but this time we'll try, say, for example, 5. Yeah, okay, so that's going to be invalid. And let's try again, maybe just with 6. Okay, right, so say, yeah, 2 items were invalid, and, right, these 6 ones were dequeued. Yeah, I mean, so I think that's working. And then, yeah, I don't know, I think, right, I'm probably not going to test it again. Like, if I was in the exam, you know, I would test it with more inputs. For the sake of, you know, keeping this video a little bit shorter, yeah, I'm just going to assume it's working. Right, so I think that's fine, and then, yeah, then output a suitable message if the queue is empty. Okay, and then we'll output the, yeah, output the return. Okay, so right, let's have 3 that are all invalid. So right, let's go 2. Yeah, right, so Q was already empty. All right, I think that's fine. And then, of course, if you were doing this properly, like where did we have 3? Right, so of course, yeah, I would then want to put this right back to 20. Although, like, to be honest, yeah, like, maybe it wouldn't even matter because, I mean, you should have copied and pasted your code for that part somewhere else. So, yeah, often it doesn't really matter. Like, just make sure it's working for these final screenshots. Okay, so looking at the test data, I realised I didn't actually do the last part of the question here. And obviously this is the problem with, having it on, well, you're having to, like, flick back and forward, sort of, well, in and out of the PDF. Now, of course, in the exam, I'd recommend, like, when you see a bullet point, right, just use a pen and just tick off when you've done, each part of the question. And obviously, well, on paper, that's going to be easier to do as well. Right, so we want to say, well, if the check digit equals 10, then it's replaced with X. Because, yeah, if we see here, right, obviously this one, right, all 9s, that's going to be an X. So I think the way we can do that then is probably in this part. Like, we just want to check, well, if the data substring, so, if we check, right, if the 7th character is equal to X, right, and the check digit is equal to 10, right, then that's also going to be valid. So I think, yeah, we can just sort of do that here. So what we want to say then, right, so data, yeah, dot substring, right, again, that's going to be 6, 7. And I guess, well, let's go equals, right, so if this is equal to X, well, and the check digit is equal to 10, right, yeah, then we can have an OR, right, yeah, or it's going to be this one. Now, I'm just going to put this in brackets, again, just so the order is correct. So what, I mean, again, what this is saying then, it's saying, well, right, if the, yeah, okay, so we say, well, if the 7th character is X, right, and the check digit is 10, well, of course, that's valid, right, or, so of course, well, yeah, this is what, or if it's not equal to X, right, then we can convert it to an integer, and yeah, check that that integer is equal to the check digit. So I think that should be okay, and like, now if we just try and test them, so yeah, let's just try and run this again. And right, I'm going to think, yeah, hopefully I can just copy and paste these in. Alright, so yeah, that was enqueued. Alright, that seems fine. Okay, right, yeah, that's also enqueued. I mean, presumably some of these are going to be invalid. Okay, right, that's also fine. Okay, right, so yeah, this one was invalid then, since it, well, it doesn't say it was enqueued. Alright, so I guess that's fine. Right then, why did that give an error? I think, was it because I pasted it up there? I mean, I don't think so. Right, so index, right, range 0, 1 out of bounds for length 0. Yeah, I'm not, okay, I think maybe that's just because I didn't paste it properly. Hang on, let's try that again. Again, I mean, that's the thing, it's quite tedious having to actually, yeah, copy and paste these all the time. Yeah, okay, right, so I guess this time it worked. Alright, yeah, just 2 more. Hopefully I don't make a mistake. Right then, enter code 11. Right, did I do less than or equal to? Alright, so yeah, okay, that shouldn't be 20, alright, that should be 10. Okay, so I've just gone ahead and run everything again. I don't think people want to see me just copy and paste again. It's going to take too long. But I think, I mean, we should get this output, right? 4 items were invalid, and then yeah, 999 was dequeued. Now, I mean, as you saw, quite a few mistakes in that video. But I mean, that's kind of the whole point of this paper. I mean, since you can test it, well, if you do make a mistake, right, then of course you can correct it. And yeah, I would also suggest, as you saw, like before moving on to the next question, then of course, yeah, just try to test each part individually. And if you have to, like rather than say having an array of 20 elements, just make it 3 elements, right, just so you can easily test it. But anyway, guys, I mean, hopefully this video is useful, and yeah, I'm not sure how long that went on for. But I mean, anyway, hopefully if it is useful, then see you again in the next video.